Okay, so there are two main approaches when you are doing multiplication. There's also a variety of tips and tricks that can be used in certain types of questions, but generally can't be applied to all types of questions. The two main types of approach are the traditional or school method. I'm referring to it as the traditional school method here, and cross multiplication. The traditional school method is generally more efficient. Cross multiplication reduces the need for visualization, and so can allow you to do larger questions than you would be able to do just using the traditional school method. And as I mentioned, there are a little bit of tips and tricks and different approaches that can be used for very specific types of questions. Okay, so in this video, we are going to be looking at the school method. And the school method is done by taking one of the two numbers and deconstructing it into individual digits and then multiplying each of those digits by the other number. So if we're multiplying 123 and 456, you pick one of the numbers, separate each of the three digits, and multiply each of those digits separately by 456. So you could separate 123 into 100, 20, and 3, or you could separate 456 into 450 and 6. By completing the steps in either A or B, you would have solved the multiplication. As a result, you're turning the 3 by 3 multiplication into three 3 by 1 multiplications and simply adding the result of each of those to come up with the correct solution. When you are multiplying two numbers that have a different amount of digits, you are going to want to deconstruct the larger number so that you have to visualize less. So if you're multiplying an 8-digit number by a 3-digit number, you don't want to multiply each of the digits in the 3-digit number by an 8-digit number. You'd rather deconstruct the 8-digit number and do 8 3 by 1s. Typically, if the two numbers you're multiplying have the same number of digits, you're going to want to deconstruct the larger number, but not necessarily. If one of the numbers has a 0 in it, don't deconstruct ending in a 0. I wouldn't deconstruct that number because it's really functionally a number with one fewer digit. If there are repetitive digits in one of the numbers, if you deconstruct a number with repetitive digits, you will have to do less multiplication because you can simply remember the result you achieved the first time. So here's an example of what it looks like to do school method. And this one, the 5,552 obviously has 5 repeating 3 times. So we're going to take each of those 5s, multiply it by 9,086, and get 45,430. Every time we move to the right, in our second number, we're moving down to the right on our work here. So we move 45,430 over 1, move it over 1 again, and then we take 2 times 9,086, and we come up with 18,172. When we do all the additions, you get the answer to the question. All you really had to do here was multiply 2 single digits by 9,086 and then do the corresponding addition. This is a somewhat repetitive example here, but again, we have a number that has repeating digits, 6,626, so it's preferable to deconstruct that number and multiply 6 and 2 by 4,793 and do the corresponding additions. Importantly, though, this is what it would actually look like in practice if you are solving the question. So we have 6,315 times 9,860. Because 9,860 ends in a 0, it's more similar to a 3-digit number, and so we're going to deconstruct the 6,315. So we're going to start with 6, multiply it by 9,860, and you'll get 59,160. But really, because we have to move over to the right when we get to the next multiplication, we can pretend there's a 0 after that. It's really going to be treated as 591,600. Then we do the next multiplication, 3 times 9,860, and we get 29,580. So you can take those two, add 591,600 to 29,580, and then we get our results, 621,180. Now, if you're solving this question and you're typing the answer or writing the answer, you can now write down 6.2 or type 6.2. If you want to be super careful, you really can only type one number here, 6, but because the next two numbers after the 2 are 1 and 1, we can be nearly certain that then it is not going to result in turning the 2 into a 3. And because the next number we're multiplying by is a 1, we are certain that that will not happen. So now we're going to do 1 times 9,860. Again, this 1180, we have to pretend there's a 0 after that, so it's 11,800 plus 9,860. That results in 21,660. We're only going to type or write the 2 here because the number after the 1 is a 6. And because it's the 6, there's a good chance that that 1 is going to turn into a 2. So now we have 622 written down or typed, and we have 1660, which is 16,600. We need to add another 0. We'll do 5 times 9,860 is 49,300, plus 16,600 is 65,900. Now, since we've reached the end, those are the remaining digits in the answer. So we've written down 622. The next 5 digits are 65900, and we have solved the question using the school method to arrive at 62,265,900. Okay, this is a video from a Japanese competition. They are going to do 10 6x5 multiplications using the school method, paper and pencil. This video is of two of the best, if not the two best competitors in Japan, and it is a credible demonstration of the effectiveness of this method. So of course, with the school method, the primary difficulty in executing the method is the visualization required to multiply a number by a second number and then keep all those digits in your head while you continue on with the calculation. It remains unclear to what extent top Sorbonne competitors can do large multiplications with the school method. For example, the standard Japanese rating exam only goes up to 6x5 multiplication, much smaller multiplication than the 8x8 standard that's used in the Western community. However, it is clear that the top Sorbonne competitors in Japan can go significantly further than 6x5 using the school method. For example, we will start with this next video of Renee doing a 7x7 multiplication on television in a live demonstration. So that was a 7x7 in approximately 9 seconds. When doing that, you have to visualize an 8-digit number. What's interesting is that you can continually increase the size of the other number without necessarily requiring more visualization. In this next video, Renee, outside of a television appearance, is going to be doing 13x7 multiplications, which still require 8-digit visualization. The interesting thing is, in this next video, she is going significantly faster than what occurred on that television show, indicating that she may have been going a little bit slow to make sure that she didn't make a mistake on live television. So this is a 13x7 recorded by her. Okay, later on in the comparison video, I will be discussing in detail the two major variations one can use with cross multiplication, which is you can go from left to right instead of right to left, or you could use multiple digits at a time instead of one digit. These two variations would also potentially exist for the school method, but I do not believe there is a rational reason to attempt to do school method from right to left. A critical requirement for using school method effectively is that you can visualize a number that is one digit more than the smaller of the two numbers you are working with. So if you're multiplying a 4-digit number by a 3-digit number, you need to be able to visualize the resulting 4-digit numbers that you create, and not just visualize them, but work with them as well. Um, so from when you're going from left to right, there is a somewhat difficulty in having to carry backwards, but because the requirement is that you need to be comfortable and confident visualizing the number and then continuing to work with it, that backwards carry is not going to be much of an obstacle. Meanwhile, if you're going from right to left instead of left to right, building that number is going to be somewhat awkward. If you need to remember the number 4,387, it is much easier to think of that as 4387 than to think of it as 7834. Memorizing a number backwards is not how our brain naturally does it, and studies are consistent in showing that that is significantly more difficult. So I do not believe there is any rational reason to attempt to do the school method from right to left. However, the multi-digit approach may be beneficial, although it is not clear to me or to anybody in the Western community whether or not that is being used in Japan or not. A critical thing in the school method is that you need to be able to rapidly do the calculation. So if it's 5 by 5 and you are doing 5 1 by 5 multiplications, that 5 by 1 needs to be done rapidly. There shouldn't be hesitation. You should be scanning from left to right and essentially without any delay coming up with the likely 6-digit answer. If you were going to break it up into 5 by 2, it is highly likely that it's going to cause delay unless you are an extremely experienced and gifted person. And so just like in cross multiplication, it would appear to have some efficiency, but it is very difficult to pull off. And it's going to make the backwards carries also more difficult as well. So it's unclear whether multi-digit school method is actually used. It could be valuable, but it would be very difficult to perform successfully.